Hey guys, what's up? So if you go to the comment section of this video, I'll put a comment that has all the timestamps. So if you only want to focus on one specific problem, just go there. That way you don't have to watch the whole video and try to find the part that would help you. Okay, so here we go. So for number 12, we go to the XY axis. Now they do tell us that sine is positive. Remember that sine is the Y coordinate. So I need the Y coordinate to be greater than 0, meaning positive. So it's either here or here, because in these two quadrants, the Y coordinate, otherwise known as sine, is positive. So now the question is, am I in 1 or am I in 2? Well, that decision is made with tangent. Remember, tangent is like a y divided by x, or like opposite divided by adjacent. But if your tangent is a number that's negative, then we cannot play in quadrant 1, because in quadrant 1, everyone's positive. So can we agree that we have to go and operate in quadrant number 2? So in quadrant number 2, let's try that again. In quadrant number 2, there we go. Let's label these sides of this triangle. So recall that tangent is SOHCAHTOA, opposite. So this is opposite, and this would be the adjacent. So we know that the opposite side, let's see, opposite, adjacent, and hypotenuse. So we know that the opposite side is going to be 7, and we know that the adjacent is going to be 5. But hold up, it's not just a regular 5, it should be a negative 5, because we moved whoosh, to the left. And then go Pythagorean theorem. I have my calculator here next to me. If you go Pythagorean theorem, you'll get the square root of 74. So the hypotenuse, which is always positive, gives us the square root of 74. Okay? So that's the point of them telling you sine is positive, to narrow down which quadrant to go to, along with the fact that tangent is a negative. So now what's the goal? The goal is here in red. We want 74 times cosine squared. So why don't we do that down here? So I have 74 times. Now I'm going to write cosine squared a little differently. You see that? I put cosine in parentheses, and then I put the square on the outside. So we have 74 times something squared, something. I just need to figure out, I got to figure out what cosine is, right? Once I know cosine, I'll put it there in the parentheses. So a quick timeout. Let's find the cosine of theta first, over here in green. Well, theta is right there in the little triangle. And cosine is SOHCAHTOA. Cosine is adjacent over hypotenuse. So my adjacent is negative 5. And my hypotenuse is the square root 74. So this fraction, you copy and paste it in the parentheses. Let's see. So I have, let's go back to red here. So this equals 74 times, well, the fraction is getting squared. Look, if you square the negative, it'll be positive. If you square 5, that's 25 in the top. If you square a square root, it kind of knocks out, so it'd just be 74. And now here, to finish off this problem, here in green, there's a 1 underneath the 74. And the 74s knock out. So all we get here is 25 divided by 1, which is why the answer key just says 25. Now let's try number 13. So let's go back here again. And look, now they're being nice. They're just saying quadrant 1, right? They're just flat out telling you where to go. So that's quadrant 1. And over here, this says secant is 4, but you know what? It's 4 over 1. Remember that? You could always drop a 1 below something to turn it into a fraction. And then what is secant? Secant is secant, so SOHCAHTOA adjacent over hypotenuse. That'd be hypotenuse over adjacent. So we know this is the hypotenuse, and this is the adjacent. So in my picture, my hypotenuse is 4, my adjacent is 1, and Pythagorean theorem would tell you square root of 15. Now, Notice that I didn't put my labels like opposite, adjacent, hypotenuse. I could have, but I just didn't. And I'll tell you why. Because let me do it in green. Let's say that here in green, I'm like, okay, this is my opposite, this is my adjacent, and this is my hypotenuse. Because my goal down here, this is my goal. And in my goal, it says pi over 2 minus theta. So recall that in class we discussed that if you have a right triangle, and if one of the angles is called theta, then the other angle could be called 90 minus theta. But 90 is the same as pi over 2. So really, in this math problem, number 13, where we should position ourselves to go for the answer is up here at pi over 2 minus theta. If this angle is called theta, this is called pi over 2 minus theta. So we're going to position ourselves right there, which is why if we now live here all of a sudden, then this adjacent and this opposite label would be switched because the original opposite adjacent labels were for theta. But we're going to stand at pi over 2 minus theta because that's the goal. So now watch, I'm going to scratch this off. I'm going to scratch this off. So now to readjust this picture, this is now the opposite and this is now the adjacent. So now let's finish this problem. Let's continue down here. So we have square root 15 times, well, let's see what this is. What is that? The cotangent of this. Well, this stuff in the parentheses just, it's like directions. It tells us where to go. We said we're standing right here. This is us right now. From here, I want cotangent. And cotangent is opposite over adjacent, this tangent. So cotangent is adjacent over opposite. You want to have all those definitions on your note card, right? So we need adjacent, which is square root 15, over opposite, which is 1. And then when you go square root 15 times basically itself, you just get back just a regular ordinary 15. So for 14a, we can rewrite this as f of 11 pi over 4, and then plus g of 11 pi over 4. Now, bear in mind, the midterm is calculator friendly, so have that out at the ready, because we'll need that for this problem. Or I should say, we could use it for this problem, and we should. So let's see. So the initial notation was that, but we break it up into 2 smaller pieces based on that FYI that I gave you guys at the beginning of class on Wednesday. So now, what do I do with this? Right? So this is telling me to go to function f, which is this one, and to plug in this number in for the x's. So I'm going to take this fraction and I plug it in there, which is literally what this says, but really I plug it in there. So this would equal the tangent of 11 pi divided by 4 plus, now what do I do with this? Kind of the same thing. You take that and you plug it into equation G, which is given by negative cosecant of 11 pi over 4, right? And then look, just go calculator. Watch, I mean, I have my calculator. Now, if I typed it in right now, I'd be taking an L because my calculator was set to degrees, but no, because we're playing with pies, you want to go with radians, yeah? So make sure you know how to change from one format to the other. So when I type this in, I got -1 for this piece. And then plus minus is just minus. Now, cosecant, my calculator does not have that button. But we remember that cosecant, right? Cosecant of theta is 1 over sine theta. So here, what I'm going to do is I'm going to go 1 over sine 11 pi over 4. And I'm good if you type in all of them. Let me actually just do them. -1 minus a fraction, 1 over the sine of 11 pi over 4. And this thing says -1 minus square root 2. So again, the focus of this class is not really arithmetic. It's just understanding, trig functions and reciprocals and properties and stuff like that, which is why I'm okay if you guys just go calculator once you can use it, right? Like you got to know that cosecant is 1 over sine. That's what you got to know. And then once you turn it into sine, go devices to get your answer. I'm totally okay with that. So that's part A. Now let's do part B. So for part B, if we go to G and plug it in, let's see what happens for part B. So this would look like negative cosecant, because it says G. So take this fraction and plug it into G. So negative cosecant of, look at that fraction, 803 pi over 2. Well, again, cosecant is not on my device, so it's up to me, the student, to recognize that I could rewrite that as the sine of that thing, but like in the bottom, right? And then I can just go here, -1 over the sine of 803, like 803 pi divided by 2. It somehow works out to give us an answer of 1, right? I mean, that basically tells you the denominator equaled -1, because the top -1 divided by the bottom -1 gave us +1, right? But anyways, yeah, just use properties to turn it into something that you can type in, and I'm okay with for a problem like this. Backyard, and we're going to tile this off 75%. So that's 3/4. Why don't you just draw something that looks like you're gonna put some tile? That's 3/4, right? It's not half, it's not full, it's 3/4, 75%. And then it's tile. So the tile is like the area. If it was a fence, we talk about like the perimeter or the circumference or like arc length. But because they're saying tile, the assumption is area. The assumption is areas of sectors. So we're talking about area. And we know from back in the day, the area of a circle is pi r squared. And they're telling us that the radius is 17. So we know that the area of the whole thing would be pi times 17 squared. And that would be like, well, what's 17 times 17? Like 289 or something like that? 289 pi. But that's the full circle. We're not trying to do all that. We want 3/4. We want 75%. So what we have to do is we have to go 289 pi times, you can go 0.75, right? You turn the percentage into a decimal. Recall that from like way back in the day. If you have a percentage, you just slide the decimal 2 spaces to the left. And let me go calculator, because we need a decimal. So 289 pi times 0.75, it says the calculator, it says about 681 square feet. That's an area. And that's not the whole circle, that's 3/4, which is the goal. So it's 681 square feet. That's how big it is. It's a big circle, right? Like a parking lot, right? For a few cars, like circle here. But then what's the goal? The goal is how much money for this project. Now they're saying that it's $5.25 for every individual square foot. Like they probably sell it like a little square tile. And you just got to put it like in your car and just take it to your house. But it's going to be a lot of tile because it's a big backyard. So to finish this problem, take 681 square feet and multiply it by 525 per square foot, right? So 681 times 525, and that's about, it's about 35.75, and that would be dollars. So the key was to take the full area, but multiply it by whatever percentage you want to fill up. If it was 50%, I would have multiplied by 0.5. If it was 25%, I'd multiply by 0.25 and so on. So that was number 15. So for 16, recall that cosine of negative theta is the same as the cosine of regular theta. So for part A, cosine of negative theta just becomes cosine of regular theta. Also recall that we said that for tangent of theta plus or minus pretty much any integer pi, you're just going to get back basic tangent. As long as k is a solid number, whether it's positive or negative, it doesn't matter if it's even or odd. As long as it's not a decimal. If this is an integer, then tangent of theta plus or minus whatever pi is basic pi or basic theta. So look, based on that, this tangent of theta plus 14 pi, well, that just gives you back basic tangent of theta. And now, based on our definitions, what could Let's go down here. What replaces cosine theta? P, addition. And then what replaces tangent theta? The letter Q. And that's why the entry key has P plus Q. So this is just playing with properties. So that was part A. What about part B? So for part B, that's a little more technical. So let me get this out of the way. And then for that one, we need to remember one more thing. We need to recall that cosine of theta plus, let's say, let me just write the word even pi. That would equal the cosine of regular theta. However, the cosine of theta plus an odd number, like 1, 3, 7, 31, 1001, theta plus odd pi, that would equal negative cosine theta. So with that in mind, let's knock out part B. So the tangent of theta and then whatever integer pi, that's just regular tangent minus 6 times. And this part here, well, look, this is cosine, and it's theta, and it's revolved an even number of pi's. An even number of pi's brings you back to where you started, which is why we get back regular cosine. So it's all a matter of the number that's attached to pi, whether it's even or odd when we're talking about cosine or sine. For tangent, it doesn't matter. You just get back regular tangent. So let's see here. So what's tangent of theta? Tangent of theta equals Q minus 6 times, and then cosine of theta was P. So Q minus 6P for the final result for number 16. Review to number 8. So what we have here is, let's say that this is the ground. And there's, let's see, a camera at the top of a building. Let's say this is the building, which is 800 feet in height. And there's a car. Let's say this is the car. And the top, there we go. The camera, you see, normally the camera, its typical line of sight would be looking ahead, like that green. But what we call the angle of depression, I will draw it here in blue. You see, this is your angle of depression, which here is described as being 37 degrees. But what we have in geometry, actually, back in the day in geometry, was this idea of alternate interior angles. And the shortcut was, I told the class, just like, whatever this is, right? Like your angle of depression and your angle of elevation are congruent because the assumption is that you have parallel lines. So this is 37 down. Let me just get rid of that. That's 37 degrees. And what's the goal? How far away from the base of the building, this is the base of the building right there, is the vehicle. So basically, we want to solve for x. So I don't need this 37 any longer. It's going to distract me, so I just get rid of it. Now I'm trying to solve for x. I have an angle. I know this is a right angle there. So I'm thinking, do I use sine, cosine, or tangent? Well, what do we have? From here, this is my opposite, and this is my adjacent. So it looks like we need tangent. Recall tangent of theta is opposite over adjacent. And so this is tangent of, well, what's theta? Theta is the angle in question, which is 37. The opposite is 800. And the denominator is x. Yeah, so here, this can be tricky. So watch how we do this here. What I could do is I could get rid of my denominator. I could multiply both sides by the variable x. Because here, they're gone. So let me continue up here so you guys can see. So I have x times the tangent, 37 equals 800. But we want to solve for x because that represents the distance between the building and the car. So to do that, we divide both sides by tangent 37 because that's just like a number. These were gone. And so in degrees, make sure your devices are in degrees. We go 800 divided by tangent 37. And that's how they get a distance of about 1,062 feet. So check the answer key. That should be it. Let's actually check the answer key here. This is number 8 it was. So number 8, yeah, about 1062, right? About 1062 feet. So here is just a matter of recalling that our depression angle goes here where it was, not in there. No, not there. It goes out here, and then you transfer it there because of alternate interior angles. Number 11 is one of those XY axis type of thing. And which quadrant do I go to? So it says that sine is less than 0, meaning negative. And we know that sine is affiliated with the y coordinate. So the requirement is that the y coordinate be negative. Well, that can work here, and that can work there in quadrants 3 and 4. But which is it? So for that, we go to the other statement. Here, they're telling us secant is this. Check out this little trick. Perks of watching these tutorials. We know that if secant of theta equals a over b, then that implies that cosine of theta would equal b over a, because secant and cosine are reciprocals. So the original statement here, we can rewrite that as cosine theta equals, it's still negative, but you just flip the fraction. And I think that's better because here we know that cosine is like the x coordinate. So we have like a negative x coordinate. So we know we have to go to quadrant number 3. So let me draw it down here brand new. So we know we're playing in quadrant 3 because cosine is affiliated with the x coordinate, like you're adjacent. And since it's negative, that means we have to go to the left. So let's see. Theta's there. I need some numbers on this picture. So we recall that cosine could also be looked at as SOHCAHTOA. Cosine is adjacent over hypotenuse. So my adjacent would be negative 3 because you go to the left. And then my hypotenuse is 4. And it's always positive for the hypotenuse. And Pythagorean Theorem would give you, let's see, 16 minus, now was that 7? But it's negative because you go down. So the triangle is legit. Now what's the goal? The goal is right there. They want sine plus cosine. Well, we don't have to worry about cosine. We know what cosine and theta is. We just have to find sine. So let's do some scratch work. Sine is opposite over hypotenuse. So my opposite would be negative square root 7. And my hypotenuse would be 4. So the goal is sine plus cosine. So I have to add together the two fractions here in green. This one with this one. Lucky for us, we already have a common denominator. So if you just combine the two fractions into one fraction here in purple, we get negative square root 7, take away 3 together, sharing a common denominator of 4. So for 12, we can rewrite this as q of negative 107 pi. And then we have minus 8 multiplied by h of negative 107 pi. So let's see, let's focus on the first part here. This is telling us to plug in this value into q. Q is sine of negative x. So, oh boy, let's see. Let's see. So this is going to be sine. And then I open up a parenthesis. And then I automatically write down that negative symbol. And then you write down the value of the input. I am inputting negative 107 pi. I want you to see that those two negatives, you know it, positive. Let's see, minus 8. And then what's up with this? H, go to equation H over there. And then, so let's see, H is defined by a negative. So multiplication, negative, cosine, and then X is what gets replaced by the stuff in the parentheses. So it should look like this. Like that there. So let's clean this up a little bit. So this is the sine of 107 pi minus 8. Well, hold up. What's that negative times that negative? Let's just call that a positive. 8 times the cosine of negative 107 pi. So now, calculator. Go calculator, type this in, whatever they said. Let's see. So this is number 12. So for number 12, they're saying, what is that, like -8, they're saying. So -8, let's see. So number 14, so let's go equals. So what could replace the sine of negative theta? One of the facts from the other day was that sine negative theta equals negative sine of positive theta. So by substitution, sine negative theta, this is a fact, right? This is just a straight up fact, an identity. Sine negative theta gets replaced by negative sine of positive theta. And then we have +2 times. And then the cosine of theta, recall what we said in class. If this number is even, then cosine of theta plus or minus even pi just gives you back regular cosine theta. That's so those properties from the other day. And so here this would equal, negative is still there. Sine gets replaced by h +2, and then cosine gets replaced by k. And that's why they have what they have in the answer, -h +2k. And then part B of that same problem, let's take a look here. So another fact to put on the board here is that the cosine of negative theta, there we go. Recall that cosine of negative theta is the same as cosine of positive theta. So here by substitution, we keep the -4. There's nothing we can do about that. But cosine of negative theta just becomes regular cosine, -6 times. And then for sine, we said that if you have sine of theta plus an odd number with a pi, that gives you back negative sine of theta. So by that fact, this becomes negative sine of theta. And let's see, the negative times the negative, since these guys are being multiplied, multiplication, this gives us -4 cosine, and then addition 6 sine. So we have a final answer of -4k plus 6h for number 14 from review 2. So section 7.3, number, what is this, 23. The goal is to evaluate the secant of pi/6 and then +2 cosecant of pi/4. So one way of doing this is recall that secant is the reciprocal of cosine. So this term could be rewritten as 1/, the cosine of pi/6 +2 times, and then for cosecant, recall that cosecant of theta is like 1 / sine. And to rewrite the other one, the first one, secant is 1 / cosine. So these are facts that we accept. And so rewriting the second piece, that's like 1 / the sine of pi/4. And from here, look, I am totally fine. Again, as I said earlier in the video, in case you didn't see that part, I'll say it here, that I'm totally fine if we go Casio calculators once you've applied like certain properties and theorems from trig. Like for instance, right now, you turned secant into 1 / cosine. You turned cosecant into 1 / sine. From there, if you want to do mental math, unit circle, calculator, I'm totally fine if you do however you want to do it. So I'm getting like a really weird answer here for mine. I'm getting like a 2 √3 plus 6 √2 all over 3. So I think this was from the textbook. Check that to make sure it's true. Should be. But for sure, turn secant into 1 / cosine and turn cosecant into 1 / sine. Then use your devices in the correct setting to get, the appropriate result. So another topic is the area of a sector. And so here's the general gist of it. If you have a circle, let's say that you have a radius of length r, and let's say that you have like a slice of pizza with an angle theta. And let's say that you want to know how much area this is. Like if you had to install a carpet or some tile, when you go to the store, you have to know how much material to buy because, we can't be spending money just recklessly. We have to know exactly how much we need to make this project. So to find the area, here's the formula that we use. Area equals 1/2 r squared theta. This is all multiplication. 1/2 times r squared times theta. The formula always has 1/2 as part of the deal. R is your radius, which is, whatever they describe the radius length of being. And this guy, that's what you call your central angle because it's an angle at the center. But, check this out. The angle there, it must be in radians. You have got to convert it to radians. If it's in degrees, you got to convert from degrees to radians. So if you do that, you get something that represents the area. We can do a quick example. Let me just delete this part here. So let's say you have a problem like this. Let's say that that this radius is like 16. And let's say that theta there, let's say it's like 2 pi over 3 or something like that. And your goal is to find the area of that slice of pizza, that sector as it's called. So we'd go area equals 1/2. And then r is 16. The square is just the square. And then theta is 2 pi over 3. And you know what I would do? I would do this, watch. In my calculator, I would type in only, watch, I'll do this very carefully. Only the red. Only type in the red. Let me do that right now. Just type in the red. 1/2 times 16 squared times the fraction 2/3. And I'm getting back this guy here. I don't know if you can see it in the video, but I'm getting back 256 over 3, and then just copy and paste the pi by hand. So if you want like an exact answer, just type in all the thingies without the pi symbol, and then you just literally write the pi symbol at the end. So that would be for areas of sectors. So recall that if you have your xy axes, if you draw like an X, let's try that again. Draw like an X, and then go straight down like that. Well, we have our 4 right triangles in the 4 quadrants. This is quadrant 1, 2, 3, and 4. And we know that we have our right angle there, and we have theta, and theta. And we know that this is like 0, this is like 90, 180, 270, and then back home is 360, right? We can just call this like 360. But another common label is to remember that this is also pi over 2, and this is pi, and this is 3 pi over 2, and we could also call this 2 pi. So that's how we label our right triangles in all of the 4 quadrants. So in section 7.6 and 7.7, what we have to do is write the equation of this sine wave, and it's given that it begins at negative pi sixths negative 1, and it finishes at 5 pi sixths negative 1, and there's a little point up here at pi 12ths comma 2. Now the goal is to write the equation. So our answer, let me get this box out of the way, our answer is going to look like this. A sine b x minus h close plus k. Let me write that down again. There we go. Our answer has got to look like this here. This is the format. And the first thing that I do is I look for the line that runs down the center. So the line would be this one here in green. And that middle line, it goes through negative 1. Look at the white coordinates. So negative 1, I know that is my center line. That's K. You see, you have to find A, B, H, and K. You fill in those values, you go home. So we know K, right down the middle. Now let me ask you this. Look at the middle line. And then from the middle, how much do we go down? I don't know because it's empty. But how much do you go up? You see, this one is at -1, but the top has a y coordinate of 2. So how much did you go up, 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 up? Did you go up 1 space? No. Did you go up 2 spaces? No. You went up 3 spaces because this is -1, this is 0, this is 1, and this is at 2. So you're going from -1 all the way up to 2. You've risen, you've climbed 3 stories. And that number 3 represents the number A. Now let's decide right here, right now. Should A be positive or negative? Well, if the graph runs up and then down, it's positive. If the ground runs down and then up, it'd be negative. So based on my picture, it's going to be +3. Another thing, H. H is the x coordinate of the beginning. The beginning x coordinate is -π/6. So I know what H is. It's always the x coordinate of the beginning. The only thing left to find to finish this problem is B. And recall where B lives. B lives in an equation. And the equation looks like this. Period equals 2π divided by B. So I need to solve for B, and I'll put it there, and then I'm done. So to find B, you need to know the period. And recall we said in class that period is the same, like I'll write it right here. Period is equal to your last x coordinate minus your first x coordinate. So go last x minus first x. So my last x coordinate is 5π/6. That's like the last point on this roller coaster, like within one revolution, within one wave. This is the last point. And then minus, and then the first would be -π/6. And that double negative is positive. And there is an invisible 1 here in green right there, which is why 5 + 1 is 6. That's like 6π/6. And the 6's cancel. So it's just pi. So your period is just pi. So the equation becomes pi equals 2π divided by B. So what does B have to be? 2π divided by what gives you 1π? Can we agree that it would have to be the case that B equals 2? Because 2π divided by 2 is just pi, which is the period. So for that reason, we know that B is 2. So final answer should look like this. And watch that double negative. You don't let that, slip. That because it's subtraction. But if H is negative, those two negatives, boom, give you a positive. So final answer right there. And now number 3 of that section, our goal is to make a quick sketch. And so let's do that. And that will bring an end to this tutorial. So we have 2/3 and then x plus pi quarters and close, and then +5. So let's go to the xy axes. Let's try that again, a little bit neater this time. And I need my 3 lines. And recall that the number in the back is your middle line. So 1, 2, 3, 4, 5. So I go to 5. And I'm going to draw a pink dotted line here. Let's see, so like that there, more or less. Okay. And now from the middle, you have to go up and down whatever the front number is. This number says 3. So from the middle, back in green, let's go up 3, 1, 2, 3, and then go down 3, 1, 2, 3. And from those 2 new positions, draw some more dotted lines. There. And down here. Yep. Now, let's come to an agreement. Should the graph go down and then up, or should it go up and then down? That decision is made by the front number. The front number is negative. Because it's negative, it's not going to look like this. I know my answer is going to look like that. I just have to grab this general shape and position it in the correct location. So you have to find the beginning point. The beginning point has coordinates, h, k. Based on what I see, I can tell you that h is going to be the opposite of what I see there. So that's negative pi quarters. K is always the number in the back, and you don't switch it. The only thing you switch is the number inside the parentheses. So K is 5. So my beginning coordinates, my initial point, has coordinates negative pi over 4, comma 5, where 5 is the middle line. So I know my beginning point is somewhere along the middle. Well, let's go in blue. Do you think that the beginning point should be like on this side? I do not, because it's a negative x coordinate. So it's somewhere over here. Where? To me, it doesn't really matter. I'm not going to be really picky with like the coordinates and all that. Just make sure you're in the right quadrant. Oh, for sure. Make sure you're in the right quadrant. And since this x is negative, we know it's going to be somewhere right there. So that's the beginning. Now you have to find the end. Now to find the end, what you have to do first is find the period. So for my period, I know the formula is 2 pi divided by b. But I know that b is the fraction that sits right there. It's usually a fraction, but it doesn't have to be. So I know that's b right there, so 2/3. So this is 2 pi divided by 2/3. And if you tap that into your devices, you're going to get 3 pi for your period. 3 pi. That's your period. That's how long it takes to go from beginning to end. So what you have to do to find the end point is you have to go the beginning, which is h, plus a period, and then keep the white coordinate, which we call k. So for the end point, you have to go the beginning, which is h, plus a period. So let's do it up here. So h is negative pi over 4, and then add 1 period. The length of 1 period is 3 pi. Get a common denominator if you want to. The common denominator would be 4, and that would turn that into 12 minus 1, which is 11. So 11 pi over 4 is this guy, 11 pi over 4. And then the y-coordinate of the endpoint still stays 5, because the beginning and end, they're along the same middle. So which quadrant is this endpoint in? It's positive 11 pi over 4, so that's going to be like somewhere over there. Again, I won't be picky with how accurate the x-axis is. Just make sure that points are in the correct quadrants. And then from the beginning and from the end, put a point in the middle, put a point in the middle and go down, put a point in the middle and go up. And the graph should look like what we said it should look, where it goes down first and then back up. So a graph like this, totally sufficient for me. Correct placement of your points with your 3 guidelines. And of course, you want to show all this work like you see here in this video. So I hope that helped. I'm not sure how much you watched this, because it was a long video, I'm imagining. So if you have any more questions, let me know. But if not, I'll see you guys on Monday night. Bye, guys. Take care.